You know that feeling, right? Your brand new, super powerful smartphone is dead, right when you need it most. We've all been there. Well, it turns out there's this invisible enemy, a hidden power drain that's holding back the AI in your pocket. And today, we're going to uncover it.
I mean, think about it. These amazing AI gadgets promise the world, but they all have this one super frustrating problem. The battery life is just terrible. It's a total paradox, isn't it? A more powerful device should be better, not worse. So what is actually going on under the hood?
All right, so the heart of this issue, it really all comes down to something called Edge AI. That's basically the AI that runs right there on your phone to do things like unlock with your face or on your watch to track your steps, all without having to send your data up to the cloud.
And the benefits here are huge. I mean, truly game-changing. When the AI runs locally, you get instant responses. You don't need a constant, perfect internet connection. And maybe most importantly, your personal data stays right there on your device, which is a massive win for privacy. This is the future. This is where everything's headed.
But here's the catch, and it's a big one. All those amazing benefits run headfirst into one gigantic wall, the battery. See, unlike a massive data center that's plugged into the power grid, your phone has a very, very limited power budget. And this, right here, is where the real trouble begins.
So to really get this, you got to understand that your device uses power in two totally different ways. And one of them is happening right this second, even if your screen is off and it's just sitting in your pocket.
First up, you've got dynamic power. This is the energy your phone uses when it's really working hard. You know, when you're playing a graphics-heavy game or editing a 4K video. The chip is firing on all cylinders. But then there's static power, or what engineers call leakage. This is a quiet, constant drain that's happening all the time, even when the device is idle. Think of it like a tiny leaky faucet, just dripping away your battery life 24/7.
So, let's think about a device like your smartwatch or your wireless earbuds. They spend most of their life just sitting there, on standby, waiting for you to do something. So which of these two power drains do you think is the real battery killer? The short bursts of heavy use or that constant silent drip?
Yep, you got it. It is the static leakage. For a lot of these edge devices, that hidden drain actually makes up a huge chunk of the total power used in a day. It's literally the reason you can go to bed with a 40% charge and wake up to a completely dead phone. Infuriating, right?
Okay, so what's causing this infuriating leak? Well, the answer is honestly fascinating, and it takes us deep down to the microscopic level, to the very atoms that are the building blocks of all modern electronics.
And here's the real kicker, the big irony in all of this. The very thing that makes our chips more powerful, the fact that we keep making the transistors smaller and smaller, is also making this leakage problem way, way worse. We're talking about components so tiny, they're measured in just a handful of atoms. You see, as we shrink these things down, the insulating layers inside them become unbelievably thin. The voltages they run on get squeezed tighter and tighter, and all of this creates brand new, unwanted little paths for electricity to just leak out. It's like the walls of the pipes are getting thinner and thinner, making them way more likely to spring a leak.
And look, it's not just us saying this. According to semiconductor engineering, the real culprits are things we can't even see. Microscopic flaws in the silicon and tiny bits of contamination from the factory. These are the hidden but powerful drivers of that battery-killing leakage.
So what are these defects, really? We're talking about things like dislocations, where the perfect crystal structure of the silicon is just wrong, it's misaligned. Or vacancies, where an atom is literally just missing from where it should be. Every single one of these tiny imperfections acts like a microscopic crack in the pipe, creating a new path for power to escape and making that leaky faucet problem a million times worse.
So if the problem is happening at the scale of individual atoms, the solution has to be just as precise. And the way engineers are tackling this is, honestly, incredible.
I mean, how do you even begin to fix a problem you literally cannot see? You can't just wipe these defects away. You have to fight them on their own turf, with processes that can control and manipulate materials at the level of single atoms.
Companies like Sisu Semi have developed this really cool process to do exactly that. First, they find where the atomic defects are. Then, inside an ultra-clean vacuum, they use a special chemical process to passivate them. Now, that's just a fancy way of saying they neutralize the flaws. They essentially go in and patch up all the tiny electrical holes. This seals the leaks, and as you can imagine, it slashes the amount of wasted power.
And you have to remember, it's all about scale. A single microamp of leakage from one transistor, That's basically nothing. Who cares, right? But your phone's processor has billions of them. Billions, what'd it be? Multiply that tiny, insignificant leak by billions, and all of a sudden you've got a massive power drain that can kill your battery in just a few hours. That's why fixing even the absolute smallest leaks is such a huge deal.
So, what does all this mean? What does fixing these microscopic flaws actually mean for you, for your gadgets, and for the whole tech industry? Well, the impact is massive. It creates a ripple effect.
The most obvious win for you, of course, is just better battery life. Plain and simple, your devices will last way longer between charges. But it also means much lower power drain when your device is just sitting there. And because the chips run more efficiently and with less stress, they actually become more reliable over the long haul. And this forces a huge shift across the entire industry. Chip designers now have to plan for this leakage right from the very beginning. Factories need way stricter controls to stop contamination. And the quality control folks, they need brand new tools just to find these invisible flaws in the first place. It changes everything. So here it is, the key takeaway. The next great leap forward in AI and our powerful little gadgets won't just come from bigger, faster processors. It's going to come from mastering the infinitesimal, from learning how to control matter at the atomic level to stop these tiny, invisible, battery-killing leaks.
And that kind of leaves you with a final thought to chew on. As AI becomes completely invisible, woven into the fabric of our lives, in our glasses, our cars, everywhere, maybe the biggest, most important breakthroughs won't be the flashy things we can see on a screen, but the invisible ones happening deep inside the silicon.